This is lesson 116 in Algebra 2, Fundamental Counting Principle and Permutations, Probability, and Independent Events. So we're going to get into some probability and statistics today. So we're going to start out with some real basic ideas as far as how to work with the fundamental counting principle. So let's go ahead and make this into 3 blocks and put A, B, and C in there, and figure out how many different ways this A, B, and C can be arranged. Okay, so I can have A here, I can put it there, I can put it there. B can be there, there, or there, and C can be there, there, or there. One of the other things that can happen too is that A, you could say, could repeat itself. It could be A, B, 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 C, C, C. Okay, it doesn't just have to be 1A, 1B, and 1C. And you can come up with all different ways in order to order these blocks. So if we just wanted to do it and say once you use A up, you can't use it again, and then this becomes BC, or if we had A, we could also have it as CB. Okay, so this particular method is when you are not allowed to use the initial letter, or the one letter you put in there, you're not able to use it over again. So let's say that we're not able to use the blocks over again. So let's go ahead and look at an example where if we have one block, what are our choices of putting that first block? We have 3 different choices, right? We can put an A, B, or C in there. Well, let's say that we put one of those letters in there, and let's say we put a B in there. Well, now how many choices do we have for the second block? We have 2 choices, right? An A or a C. So let's say we picked C. And how many choices do we have left then? If we used a B and a C, we only have 1 choice left, right? Alright, the fundamental counting principle says that if one choice can be made, in this case in 3 different ways, in this first one, and another choice can be made here, and third, another choice can be made here, then the number of possible choices are going to be 3 times 2 times 1, which is 6. So that is saying that if we were to take the A, B, and C and arrange them and put them here, here, and here, there would be 6 different ways to arrange these. A, B, C, B, A, C, C, A, B, A, C, B, B, C, A, and C, B, A. Those are the 6 ways that you can arrange those letters if none of them were able to be repeated. So if once one was used, then you can't use the other one. Okay, so we get what is the fundamental counting principle, which means if we had 4 in one, let's say that we had a box and there were 4, the next one gives us a chance of using 3 because we already used 1 there, so we only have 3 left, and then 2, then 1. So that would be 4 times 3 times 2 times 1, or 24 possible ways to arrange, let's say this was A, B, C, and D. So when we make this list here, instead of there being 6 there, when we put that 4th box on there, it would be 24 different ways that we could arrange these. So we'd have a list of 24 different ways. Alright, so the different ways that we arrange these has a name for it, and it's called a permutation. So one of the ways of doing that would be a permutation. We call each different arrangement of the members of a set in a definite order a permutation of the members of that set, is what the book says. Okay, so if for example, instead of doing it the way we did, where we're saying you cannot repeat, let's say that you can repeat. Let's say that we have 3 places here, and we're using A, B, and C, but I can repeat, okay? And I can also just repeat 2 of them, or just 1 of them, okay? So if I do that, then I have a choice of 3 letters here, and if they can repeat, I have a choice of A, B, and C here, and I have a choice of A, B, and C there. So that gives me 27 different options or different permutations or ways of arranging A, B, and C if I can use A 1, 2, or 3 times, B 1, 2, or 3 times, or C 1, 2, or 3 times. Okay? So when I do these first bits of examples, I think, oh my gosh, this is so confusing. So we go into the examples, and sometimes the examples just kind of clear things up. So let's look at 116.1, and it says how many different ways can the numbers 3, 5, 7, and 8 be arranged? Okay, so basically I have 4 different places for 3, 5, 7, and 8 to go, and I can put them in any order I want. I can go 3, 5, 7, 8 for the first one, 3, 7, 5, 8. I mean, how many different options are there possible? If, and this is what the instructions say, if no repetition is permitted, which means the 3 can't occur more than once, the 5 can't occur more than once, etc. All right, key thing here is I don't care what these numbers are. I just need to know how many of them there are. So for this first spot here, how many different numbers could I put here? I can put a 3, a 5, a 7, or 8. So I have a choice of 4 different numbers I can put there. Well, if they can't be repeated, then once I put a number in here, it's locked there and I can't use it again. So let's say I put a 3 in there. It's gone. Now how many numbers can I put in the second box? I can put 3 in there. So let's say I put a 5 in there. Now how many numbers? I can put 2. I have a choice of a 7 or an 8. If I put a 7 in there, I have a choice of 1. Alright, so the different ways, 4 times 3 is 12, times 2 is 24, times 1 is 24. Alright, so you should have a key on your calculator that will help you with this that looks like this. That's called a factorial key. So, factorial. Alright, so factorial means that you'll put a number in there, like 4. You put a factorial, and that means 4 times 3 times 2 times 1. So you just push the 4 and then the factorial key, and it should give you 24. If you put a 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1. Okay? So you take your calculator and you push 6 and then the factorial key, and it will multiply all these numbers together for you, so you don't have to do that. Okay, now the factorial key only works on different ways that numbers can be arranged if no repetition is permitted. If repetition is permitted, you can't use the factorial key, but there are other ways, things that you can do that make it easy. Okay, let's look at 116.2. How many 4-letter signs? Okay, so we're looking at 4-letter signs. So 4 letters, 4 spaces, can be made from the letters in the word equal. Okay? If repetition is permitted. Okay, I don't care what the letters are. I just need to know there are 5 letters in that word. Okay, that's all I care about. So, that being the case, I'm trying to make 4-letter signs that contain the words, the letters E, Q, U, A, and L. Okay, so if let's see, it says if repetition is permitted. All right, so how many different choices do I have to go in this first box? I can put an E, a Q, a U, an A, or an L, right? So I have a choice of 5 different letters that can go in that box. All right, if I was not allowed to repeat, then the next one would have 4 because I already used one, but this example says that we can repeat. So let's say I put an E in here. How many options do I have for the next one? Well, I still have an E I can put in there because I said it could repeat. So I still have 5 options. Still have 5 options. Still have 5 options. So what I have is 5 to the 4th power, and that's what I was saying. If they are allowed to repeat, you're just going to get something like 5 to the 4th power. Plug that in your calculator and you'll get 625. So there's 625 ways that E, Q, U, A, L can be arranged in here. All right, so maybe you use E, Q, U, A. Okay, it doesn't matter we didn't use the L in there. I mean, we're just trying to use the letters E, Q, U, A, L, 5 different letters, putting them in this 4 space block. Okay, so obviously every time one of the letters is going to be missing, but that didn't matter. All right, so that's what's going on there. All right, let's continue on to 116.4. 116.4 says, or I'm sorry, 116.3, a multiple choice quiz has 8 questions. There are 4 possible answers to each question. So let's say there's that, and that. So it's kind of like you have a choice of A, B, C, and D. Okay, those are your 4 choices for each of the 8 questions. Okay, how many permutations of the answers are possible? So question 1 has A, B, C, D. Question 2, I have a choice of A, B, C, D. All right, if I answered A for question 1, is it okay for me to answer A for question 2? Yeah. I mean, you can have A for the answer for both of those questions, so therefore they are repeatable. We can repeat A or B or C or D. It doesn't really matter. All right, so how many questions do we have? We have 8 questions, and each one has 4 choices. Okay, so what we've got here, let's make this into each one of these boxes one of the questions, okay? 1, 2, 3, 4, 5, 6, 7. Okay, there's our choices there. So how many choices do we have there? We can answer A, B, C, or D, right? In number 2, how many choices? A, B, C, or D? A, B, C, or D? Each one of the questions on this quiz, we can answer A, B, C, or D. So we have 4 to the 8th power, right? So that means, as far as possibilities, there's 65,536 different possible ways to arrange A, B, C, and D for each of those 8 questions, because we could have B here, we might have answered A there, maybe we answered C there, maybe A there, B, D, C, C. There's one permutation of the 65,536 possibilities. So rather than actually do each one of these to find out how many there are, write this over and over and over in different ways till we get, okay, 65,536 different methods. No, we just say we have 4 choices in question 1, 4 choices in question 2, 4 choices in question 3, 4 choices in question 4, etc. You thought I was going to do every one of those, didn't you? So 4 to the 8th power then would tell me how many permutations or choices I have there for that one. Okay, so that's it for video A, 116A, and let's continue with 116B.